Hi everyone and welcome back to the course. In this video, we'll talk about Podman and how to manage your containers with Docker. So before moving to the practical exercises, let's first talk about Podman. Podman is a native open source tool that doesn't use daemons or background processes. It's designed to facilitate the search, execution, construction, sharing, and deployment of applications using open continuous initiative. The key feature of Podman is that it doesn't need daemon process for controlling the instances of each container. This provides opportunity to access various visualization applications without root privileges. So Podman is a container engine that allows us to lift containers in a similar way to Docker, but with some key differences that you can see here in front of you. The first one is, as I mentioned, it is rootless. So it doesn't need root privileges in order for us to execute containers. So thanks to the Podman modular architecture, it is not necessary to execute our containers as a root, which is quite a big advantage as we can execute our containers with different users who have different privileges. This happens without the risk for someone who has access to container to execute the container as root user. The second main advantage is that it is daemonless. It doesn't need to raise a single daemon for many services to work. So Podman is quite similar to microservices architecture and executes the necessary services for each container. Then you have the pods. So Podman has pods, which is actually a term that also comes from Kubernetes. So we could lift pods from one or more containers and isolate them from their pods. As you know, pods are small deployable units of computing that you can create and manage. Pods are usually a group of one or more containers with shared storage and network resources. And finally, Podman has a command line tool, quite similar to the one of Docker as well. So there are not much differences there. So if you started on Docker and you wanna move to Podman, then you don't need to actually learn as many new things. So in addition to the fact that you don't use domains, as we mentioned, one of the key features of Podman are the pods. So pods allow us to fuse multiple containers in a common Linux namespace that shares specific resources. You can also apply a wide variety of visualization in the same way. So in that way you can run multiple containers as a user without root privileges. So the main idea when using Podman is to have a main container that has inside one or more side containers running in the same pod of the main container. In this way, containers within the same pod cooperate with each other to execute a particular service. So here I bring you some of the most interesting characteristics that Podman actually has. The first one is that it has a syntax that is quite similar to Docker, so you don't need to learn new set of instructions to manage your images into the containers. And yes, Podman actually manages the entire container ecosystem, including the pods, containers, images, volumes, and this is done by using the libpod library. And so if you see this GitHub webpage, you can see that you can mount Podman Compose and you can use it as a Docker Compose from here. But let's leave that page for now and let's check out what are the Podman commands. So I will open here a terminal and I will get a little bit closer so you can see. And first of all, if you want to check out all Podman commands, you can simply go to docs.podman.io and here you can see the different commands related to Podman. As I said, they're quite similar to Docker, so it shouldn't be that much of a learning curve there. So guys, in order to install Podman into your device, you can go to podman.io, getting started installation, and you can simply write brew install Podman for macOS. For Windows, you can click on the separate guide, or if you have Linux, you can check your Linux distribution from here and then write the appropriate command. Since I'm using macOS, I would just need to do brew install Podman. Brew is actually another service that if you don't have it, make sure that you install it. So go to brew.sh, copy this command right here, okay? And you can install Brew, which is the installation tool. So I already have it installed, but I will just paste that here and run it. It is a root privileges command, so write your password, okay? And then Brew will start installing inside your device if you don't have it installed yet. So once this is installed, then you can install Podman by simply copying Brew install Podman, okay? Click enter, and then since I already have it installed, I will see this message that Podman is already installed and up to date. But for you, since you don't have it installed, it will take you about 5 to 10 minutes until the installation is completed. So if you want to check all the commands that are available for Podman, you can simply do podman -help, okay? And you get all the commands that, as I said, are quite similar to the ones of Docker. So in order to use Podman, firstly you need to do podman machine init, and once you write this command, then a CentOS image will start downloading into your device. And this is because Podman uses a Linux system to operate. So you can start now the machine by writing podman machine start. So let's do that. Okay. And now your virtual machine for Podman will actually start. So now your machine has started successfully, as you can see in the background. And if I write PS, you can see that there are also some processes in the background as well. So let's get our Docker container with this command podman pull docker io library httpd, okay? And you can see that now we're pulling our docker io into Podman. So this is completed. So then let's do podman images, and here you can see the list of all the images that you currently have, and obviously we have only the docker io image that we just downloaded. So now let's run it in the same way that we were running containers in Docker. So here we use the same command actually, which is the run command. So let's do podman run -dt-p, then specify the ports, the protocol, and finally the image. Let's run that. Okay, and now here you can see the process which you have running into your background. But how you can find your process? So if you do podman ps, okay, you can see that you have one process in the background that is currently running, and this is your Docker image, as you can see. So now if you do curl http localhost and the same port that we stated for our Docker container, you can see that we're getting something, which means that this works. Okay, so this is the output message here. And so let's inspect the container that we just created by firstly writing podman ps, and you can see here the name of the container, or the ID actually, and you can simply write podman inspect and then just copy and paste the ID. Okay, so you can see now the configuration of all containers in our device. So here is the ID, and we only have this Docker container that we downloaded. And so if you need anything related to its configuration, you can definitely check it from here. Now, another cool feature of Podman is that you can actually search for images. So let's do podman search Python, okay? And you can see here all the images related to Python that you can actually download in your device. And you can download them by using the pull command in the same way as we did with the Docker image. So now let's actually close our container and exit Podman, and you can do this quite easily by doing podman stop, and then let's place the ID of the container, and this command will actually stop our container, okay? And you can also do podman rm and then the ID of the container, and you can see that now, since we get this ID back, our container is removed. So if I write podman ps, you will see that there are no processes running. Or if I do curl, you will see that there is absolutely nothing. So we failed to connect to the port because the port 8080 is no longer connected to our container. So I know that Podman might not be as intuitive as Docker, since Podman doesn't have a graphical user interface, but trust me, it is quite a powerful tool that you can definitely use. So you should know that using those tools, managing containers, have completely changed the way people think about software development, deployment, and maintenance. Containers are so light and flexible that they've given rise for new architectures and applications. This new approach consists of packaging the different services that are part of application into separate containers and then deploying those containers within a cluster of physical or virtual machines. When developing a simple code, the administration of that code doesn't require large resources. So the need for container orchestration starts appearing into the project. So container orchestration is a tool that automates the implementation, administration, scaling, the creation of networks, and the availability of application based on this technology. So nowadays, applications are quite complex and tend to appear towards microservices, meaning that we should have at least one container for the front end and one or more service interfaces and another for database. So all of these things give the need for the container orchestration that is having a tool or system that automates the development, management, scaling, interconnecting, and availability of container-based applications. The container orchestration is basically responsible for the development and deployment for automatic container-based services, for the self-scaling and the load balancing of the system, and to control the health of each container. So to do that in Docker, you can actually use the Docker Compose. So Docker Compose, as you can see here, we're on the front page of Docker Compose, and it basically allows you to connect several containers and execute them with a single command. It is implemented in Python and it uses a file called YAML based on the YAML makeup language. So the Docker Compose allows you to define a series of containers and the relationship between them at a level of a YAML file that is very intuitive in its format. So as you can see, this can be done in a few steps by creating a dictionary of the project, for example with Flask, creating a Docker file, and compose file, which is actually our YAML file. This file includes all the dependencies and their interrelations. This allows the management of multi-container applications, and to manage that, the techniques that you need to use don't actually differ from the standard techniques that we use with a single container. With the Docker Compose command, the corresponding subcoming commands actually manage the entire life cycle of the application. And right now, we will not actually go into too much detail on how to do that. I just wanted to show you the front page so you're aware of this, but we will definitely explore this more and apply it to our application. So we will definitely have projects where we will create a Docker file, YAML file, and so on. The YAML file basically has all the libraries, volumes, ports, and other important information for each of the containers that we have. So that's it. Thank you very much for watching this video, guys. And in the next video, we'll talk about Kubernetes. So I can get you started there. And then in the next sections, we'll explore how Docker and Kubernetes are basically one of the key components for building the DevSecOps. Thanks for watching.